So now let's get into some of the math that you're going to have to deal with when you deal with acids and bases. Again, for the introduction, we'll go into easier calculations. But once you get a good handle on this, then we'll actually get into equilibrium, and so your ICE table will be back and everything else. But let's just focus on the intro part of this first. So just a little bit of background on where it is that your equilibrium expression is going to come from. Basically, if you were to do something called self-ionization of water, or just basically if you were to have H2O together with H2O, what would it form from there? Well, if you were to write H2O differently, as HOH, let's say, basically what happens is that H can act as an acid, so basically it gives up an H. So if it gives up that H, it'll go to the other H2O, and that's where your H3O plus comes from. And then because the H gets added onto that water, you're left with OH, and that's where that comes from. So basically your equilibrium expression in this case is coming from this self-ionization reaction. And H2O is a liquid, so that's why when you do out your in this case KW expression, that's why you don't have water in here, because of the fact that it's a liquid. You only have H3O plus and OH minus, which it has been given a value, which the value for KW is 1 times 10 to the negative 14th. So this equation you're going to use quite a bit to be able to go from one concentration to the other. So here's just one of the examples of that, where you're looking for OH minus concentration, and you have 1.5 times 10 to the negative 10 molar HNO3, which if you were to look at this, you determine that this is an acid, because it has an H in front of it. And so, because it's an acid, it's going to give up an H. So it's going to form your H3O plus here. So basically all you have to do is just substitute this value in, the 1.5 times 10 to the negative 10, in for the H3O plus, and then your OH minus would be your X. So just solve for that, and you should end up with a value of 0.0000667. So 0.0000667 molar. And that would be the concentration for your OH minus in this case. One last example I want to show you, this is something I need to touch on. In this case you have CaOH2, so automatically you can see that it is going to be a base. But what I want you to pay attention to is just a subscript that's here. You do need to take that 2 into account when you're figuring out your concentration. Much like, let's say you had H3PO4. If you had something like that, you would have to take that 3 into account as well. Because you don't only have one H plus ion, you have 3 H plus ions, so you do need to take that into account. In this case you have 2 OH minus ions that you have to take into account. So the way that you do that, in this case you have 1.03 times 10 to the negative 4. All you do is multiply it by 2 because you have 2 OH minuses. And if you do that, you end up with a concentration of 0.000206. So that becomes your OH minus concentration. Now that can go there. So if we were to plug this in, you'd have something like that, and then you would just solve for X. So you'd end up with 4.85 times 10 to the negative 11. So the calculations aren't that hard. It's relatively easy to be able to do this. It just makes sure that you remember about the subscripts, being able to take into account the number of OH minus ions you might have and the number of H plus ions you might have.